Hi, this is Aaron Holmberg from Corvallis Middle School. This video is designed to explain what cross-canceling when you multiply fractions is and why it works. So this is what cross-canceling looks like when students see it, and it's introduced as a good 5th grade skill in just multiplying fractions. But as time goes by in 6th and 7th grade, students have larger problems they might be working with, also things like proportions. That they can use cross-canceling to solve there. So cross-canceling is a really important skill that kids use in 5th, 6th, 7th, and 8th grade and so forth. You can use it in high school also later when, again, your equations get larger and larger, and you can factor out things by cross-canceling. So that's what it looks like. And here is a real simple fraction problem. And students have been used to and been taught to multiply fractions. When we multiply fractions, of course, you don't need a common denominator. You just multiply straight across. So 6 times 14 is 84. And 7 times 15 is 105. Now, teachers always ask for a problem like this to be reduced as a final answer and not to leave it with such large numbers. And students would be expected to then think about what is a common factor that they can change the top and bottom by to make a smaller and smaller fraction until the numbers involved in the fraction in the numerator and denominator don't share a common factor, or perhaps they're prime even. So students would get to this 84 1/5 like this, and if they recopy line by line, they might come around to the idea, well, they know that 84 is 7 times 12, and 105 is 7 times 15, and realize that they have a factor of 7 that they could cross off. They could just ignore and say, I'm going to take off this factor from the top and the bottom, and that evens it out. It preserves this proportional relationship between the 84 and the 12 and the 105 and the 15. In other words, both of these have been divided by 7, which means that you're just looking at a smaller piece, a proportional piece of this larger fraction. When students get to this one, hopefully they'd recognize that 3 is going to go into each one of these. So 12 is 3 times 4, and 15 is 3 times 5. Again, they would take the common factor, and they're basically dividing it away. And so 84 is to 105 as 4 is to 5. 4/5 is a proportional fraction, or an equivalent fraction, is what we would say. So that equals 4/5. Now, this takes a lot of work, and cross-canceling is made to make that a lot easier for students. You can see on the original example that I started with, cross-canceling in this case would look like this. And that amount of work to come to the 4/5 answer is much simpler and faster than doing all of that work to come to 4/5. And so we're encouraging students to understand that this work is behind it, but really to do their work like that. So the first thing that cross-canceling is it's a form of reducing fractions by proportional amounts so that you can come to a reduced answer more quickly instead of factorization like this. So again, what is reducing? Some students still want to know that, and maybe some folks might forget that as parents too. So I just have this array here, and this array has 1, 2, 3, 4, 5, 6 boxes by 8 boxes. So there are 48 total squares here, and I've put circles in some of them. You can quickly see that that's 8 of them. So that means that 8 of the 48 have the circles in those boxes. But I could reduce that, and I could reduce it here by knowing that there is, well, I don't want to go too fast. I want to make this kind of intermediate step. You might notice here that some of these lines that I've drawn in the boxes are a little bit darker than the others, and because that helps you see that I could say that 4 of these could be like 1. And if I look at my whole diagram, I notice that I have areas that contain the fourths, or contain these 4 pieces. And this is a way of visually showing what reducing a fraction means. It means just grouping up smaller parts. And I'm going to have a changed fraction here that's going to have the same relationship to the pieces and the whole, but I've just made each piece a little larger, containing 4 equally. So in this case, I have 1, 2 squares here of the 4 out of the group of 12. So it kind of looks like I have 2 12ths there. But that can also be reduced. And I'll use another color to show this. You might notice, well, if I take those 8, and here's one group of 8, and here's a second group of 8, and a third group of 8, and a fourth group of 8, fifth group of 8, I've got 6 groups of 8. So in that regard, if I were just to make it even a little more obvious, make this a little bigger, I have 1/6. I have 1 out of the 6 groups of 8 there. And so if I were to reduce it there, 1/6. Now we could have gone there, and that's what I was almost showed you too fast. The 1/8 like this, to show back on that earlier model, we teach students that that's 1 times 8 to make the top, and it's 6 times 8 to make the bottom, and the common thing that's being crossed off is the 8, and that's because you have 8 parts inside of it. So you're factoring away the 8. It's like you're ignoring the 8 little pieces in each one of them. And right here is your 1/6, which is the reduced fraction. So that's just going on with reduction. That's all reducing is. Okay, so cross-canceling. This was my starting example here, and I'll show how you would cross-cancel that. Ooh, where did I work it out? I'm going to take this one that I started with in the very beginning and show that I don't need to do all of this work to come to that 4/5 there. What I would do instead is I'd ask myself, how many 6s go into 15? Oh,